Hi, my name is Michael Nadeau, and this is my ISA 4220 presentation on SELinux and HTTPS. This is the overview. First, we're going to go over SELinux, which is Security Enhanced Linux. We're going to have a technical discussion, and then go over the best practices. Also, we're going to go over HTTPS, which is a Secure Hypertext Transfer Protocol. We'll do the technical discussions and also go over the best practices. First, we will be talking about SELinux. SELinux was developed by Red Hat Enterprise to be a security feature for Linux. This is why it is entitled Security Enhanced Linux. To enable Linux in the early 2000s, one had to apply patches to the kernel. This was the process up until 2003 when SELinux was included in all the upstream Linux kernels. SELinux is thought by many to be a hard service to grasp and understand. This is usually the case because of how poorly SELinux performed in its first days. It was a nightmare even for the developers to understand. But today they have fixed their issues and SELinux is simple to understand. In this presentation I'll be discussing the important parts of SELinux. First we will talk about how SELinux handles access controls. Then we will talk about how SELinux identifies which files to manage and in which way. After that, we will talk about how SELinux enables certain SELinux settings, and then we'll talk about how it specifies the policy management. And lastly, we'll talk about the type enforcement. First, let's talk about Mac. No, this isn't the computer. This is mandatory access control. Traditionally, Linux and Unix systems use discretionary access control. This means that the user has the ability to change their permissions. So let's say if a user wanted to get themselves read-write access and execute access, they can just type a command and it will give them those full rights of either the directories or services. This can cause a lot of problems. If a user makes changes to wrong directories or processes, they could determine their system. Not only that, full access permission change can grant an intruder access to the whole network through one infected computer. To fix this issue, SELinux went to a mandatory access control, meaning there's policy around what and how a directory or process is to be accessed. These policies and how they are applied are administratively handled through SELinux. SELinux's policies control more than just the directories and processes. They can control how a network communicates. Next is labeling. To understand labeling is to understand SELinux. It is crucial to know how labeling and type enforcement works and how it affects how SELinux runs. There are four types of labels: user, type, role, and level. Type is the most important and most dealt with when you deal with labels. There is a different type of policy also. It is called targeted, which means full policy is enforced. Then you have the limited policy, which means that the policy has been edited in some way. And then there is a secure policy called MLS. So when labeling occurs, it places each process in a category, and only that category can access its own type. Meaning if I have a web server and it is listed HTTPD type and it wants to access DHCP type, it cannot. This is similar to how hardware interrupts are handled in my section where I talked about operating systems. So this is called the type enforcement. So to put it in simpler terms, just think about a process running which is type A and you have a directory type B. They won't be able to access each other. The process type A would only be able to access the directory with the type A. Now let's talk about booleans. Booleans are quite simple. SELinux has a number of settings that can be turned on or off. These settings that I'm talking about are not just for whole application or processes, but rather part of them. Just think about it this way. If you have a Windows firewall application, inside that application you have a number of settings that you can turn off or on. The way SELinux understands if you turn them on or off is with a bit comparison of either 1 or 0, basically an on or off switch. So let's say a user wants to see all the booleans that SELinux offers. They would just have to enter get sebul -a and then run it. This will list all the booleans, which are a pretty significant amount. To actually set the boolean, you would pass the command set sebul and then specify the boolean and then a 1 or a 0 afterward. You can make this boolean permanent by putting a -p, but it is not advised. Next, we are going to talk about troubleshooting. There is a lot that we can go into about actual troubleshooting, but I want to focus more on the tools for troubleshooting. By default, SELinux does not have any troubleshooting help inside of it for when you run into an issue. But there are two plugins called SE Troubleshoot and SE Troubleshoot Server that will save you a tremendous amount of time when you run into problems. How it works is if someone runs into an issue, like you type a command for a user to have a web page and it doesn't work, you can look into the error log messages, and inside the logs it will list out the error that occurred, and then it will tell you why it occurred, and then there will be a line underneath with a command that you can just copy and paste and run, and it will fix the issue. So for SELinux, this tool, either SE Troubleshoot or SE Troubleshoot Server, will make troubleshooting a breeze for you, and highly recommend it when you install SELinux. Alright, now since we got done talking with SELinux, I'm just quickly going to go over the best practices for SELinux. It's going to be a very quick slide. First, you want to enable SELinux. Usually by default with CentOS, it is already enabled, but you want to make sure that it's enabled. I went over that command in the previous slides, so if you want to go back, it's just a command you run and you can see if it's enabled. Next, you want to install the SE Troubleshoot and the SE Troubleshoot Server, for being that it's a lot easier to troubleshoot your problems. Next, you want to set all the policies to enforcing. Make sure you have all of them enforcing. If one's not enforcing, then you're vulnerable. Then you want to leave SELinux running everywhere. Same thing as above. You'll be vulnerable if it's not running everywhere. And then you want minimum system privileges for all the applications. Well, now that we have finished the presentation on SELinux, now we are going to discuss HTTPS, Hyper Transfer Protocol, and then the S is for secure. So what we're going to be talking about first is HTTP, the commands and response code, and then we're going to talk about HTTPS, which is the SSL or TLS, and certifications. So let's begin. First, we will be talking about SELinux. SELinux was developed by Red Hat Enterprise to be a security feature for Linux. This is why it is entitled Security Enhanced Linux. To enable Linux in the early 2000s, one had to apply patches to the kernel. This was the process up until 2003, when SELinux was included in all the upstream Linux kernels. SELinux is thought by many to be a hard service to grasp and understand. This is usually the case because of how poorly SELinux performed in its first days. It was a nightmare even for the developers to understand. But today they have fixed their issues, and SELinux is simple to understand. In this presentation, I'll be discussing the important parts of SELinux. First, we will talk about how SELinux handles access controls. Then we will talk about how SELinux identifies which files to manage and in which way. After that, we will talk about how SELinux enables certain SELinux settings, and then we'll talk about how it specifies the policy management. And lastly, we'll talk about the type enforcement. So, HTTPS. So what does the S stand for? Well, like I said in the last slide, it stands for being secure. And why is there a need for HTTPS? Well, you don't want your information to be going over to a network and it be sniffed off the network. So if someone did have an understanding of how HTTP worked, and they're sniffing the wire, and they got some of your information or a steady flow of your information, they'll be able to read that and translate that very, very simply. Well, the secure makes that request over the line, it encrypts it. So there's a huge need, especially let's say in credit card information. You go buy stuff off of Amazon and you're putting your credit card information. Well, if the person's sniffing the wire, they'll easily be able to get your credit card information, and then there goes all your money and then your credit scores. So this is why we have HTTPS. Alright, now let's talk about encryption. SSL and TLS encryption. These use a asymmetric key encryption, meaning there is a public and private key. This is a very hard concept to wrap your mind around, but I'll try to explain it to you. But first we must understand what certifications are, and those are, so if I'm a website and I want to get a SSL certification or TLS certification, I would send it to a CA, and they would either authorize me to have a TLS certification or a SSL certification. If I do get these, then I'll be able to transfer an HTTPS. Also, what that does is it loads it into the browser database, and so the browser database should have the public key. Well, when you make public keys are the basis at understanding this. So basically you want to post your public key everywhere, so everybody knows your public key. Same with the server knows your public key, and this is very crucial. So if I know your public key, let's say I'm connecting to a server, I know its public key. It has a public key and private key. His private key is the only thing that can decrypt the public key. So if I make a message using a public key, the message is all jumbled up. When it gets to him, his private key is the only key that can decrypt that. So what happens if I want to make a request? Let's say it also does with identification. So if he has my public key and I encrypt something with my private key, to make sure that that information is sent over to the server safely, because if my public key's out there, anybody could decrypt it because I'm encrypting with my private key. Well, what happens is, since he's certified, I know he's a trusted source, I can go ahead and send my private key information, or the encrypted information from my private key. And how I secure that is I secure it with his public key. So if I'm securing it with his public key, that means only his private key, which no one knows, is able to open that message. Once that message is open, he'll see my private key encryption and then be able to unencrypt that with my public key. Very hard to understand, but hopefully I made it easier for you to understand. But this is what SSL and TLS use. It's called the handshake. Now we're going to talk about the best practices of HTTPS. First, you want a 2048-bit private key. Make sure it's long enough so it can't be guessed or generated. You want to password protect your private key just in case someone does get into your system and is able to access your private key. Then you want to use a reliable CA so people can trust your certification, and that if some users don't trust the certification, they'll still be able to get to your website. Next, you want to use a secure protocol. And then last, you want to disable known problems such as insecure negotiation, TLS conversion, and so on.